All right, physics. So last, a very, very last thing before the quiz on F Day. Um, Hopefully y'all have a good handle on how to interpret these questions, how to look at, free, whether, is it free fall? Is it traveling left, right? Do I know the initial? Do I know the final? Do I have to worry about the whole time? Do I have to worry about how long it takes to get to the top? You have all this information. There's one scenario that might trip you up, and I'm going to give you an out. I'm going to give you a way to solve it that will make your life a little easier. All right. It's going to involve a new equation, but the new equation is helpful, and it will be useful to you for a while. So, all that being said, I should find the. All right. I need to just make sure that I. Okay. Sorry. The beauty of. Okay. I'm just making sure I have a reference table that I can actually use here. So, here's the deal. We're going to look at a new equation, and I'll come across it, and I'll explain why we have to use it in this context. So, the scenario is going to be really similar to what we've had before, and it's going to look like you can get to where we need to be, but we're going to just be short a little bit of information. All right? So, here we go. And here is our scenario. What? What's happening? Why is there? Excuse me? Why does it... Alright, I don't know what's happening. A driver going 25 meters per second sees a deer and slams on the brake. They stop after going 30 meters. Let's not ask it like that. Let's ask what acceleration does the driver feel? All right. So let's take a look at this question. Let's analyze this. Let's kind of pick this apart, right? The way that we have been. So driver going 25 meters per second, that sounds like an initial velocity. That's how fast they're going when we start. Sees a deer and slams on the brakes. All right, so we're going to be slowing down. They stop after going 30 meters. They stop. So at the end of this, we know that they are stopped. We know that the final velocity is 0. And we know that their change in distance is 30 meters. The question is, what acceleration does this driver feel? So what's the acceleration? And previously, if we had wanted to solve this, we would need time. The problem is, we don't have a way to find time. You may be thinking, but Mr. Kalimlan, don't we know that velocity is just change in distance over time? We do. But only when acceleration equals 0. And we know that in this case, acceleration can't be 0 because we're trying to find it. So, this equation is no good. What we're going to have to use instead... Hey, look, a physics reference table. I'm going to go all the way to the last page. Right? We've talked about this equation. We've talked about this equation. We've talked about this one. Talked about this one. It's this fifth equation that I won't highlight because it just makes it kind of look bad. But the fifth equation. All these other ones have like a reasonable explanation. They were the slope of a line. They were the equation of a line. It's the equation of a parabola. I swear, I promise, that this has an actual explanation. However, right now, it's kind of just like a magical Christmas land explanation. It works because it works, and that's just where I am, right? We don't have enough physics concepts right now for me to explain it fully, so you're just going to have to trust me and the reference table. Now, this equation can get rough when it comes to calculating because there are a lot of 2's. There's a VF squared, a VI squared, and a 2A. It's not delta, it should be delta D, right? I every time there's a distance here, I like to make it delta distance, the change in distance. So I'm going to write that equation. VF squared is VI squared plus 2A delta D. I like to make, like I said, I like to make that a delta D. My hair is just doing this thing. I'm sorry. I'm easily distracted. All right. I'll just turn this way. All right. So I think I have the numbers to find my acceleration, and I don't need time. I will refer to this as the timeless equation because it is your get out of jail free card when it looks like you don't have enough information, when it looks like you're missing time. You'll probably be able to use that equation. All right. So let's plug in numbers. 0 equals 25 squared plus 2 times acceleration times 30. Now, normally, I would put the units in here, but I have written the units here in my list of variables. Because I have my units here, I know that this 25 is 25 meters per second, I know that this 30 is 30 meters, and I know that this 2 is just a leftover from having written the equation, right? And this is just to clean up so I don't get confused when I'm doing math, like, what is this supposed to be? So I know that 0 is 625 plus 60 times A. And now I need to solve for A. So negative 625 equals 60A, and A is about negative 10.4 meters per second squared. That's the acceleration the driver feels, is 10.4 meters per second squared backwards, right? Because the driver's going forwards and all of a sudden they slam on the brakes, whoomp. You kind of get jarred backwards into the seat. Now for reference, this is not a comfortable acceleration. This is bigger than the acceleration due to gravity. So that feeling that you have when you jump in the air and you're being pulled downwards, it's bigger than that and pulling you backwards. The reason this is real bad is because people don't like that. The car was going fast and the car's not going fast anymore. And as a result, you were going fast and now you're not going fast anymore. But not only does your spine and your shoulder blades and your rib cage, like they all suddenly stop. All those other bits that are in you, I refer to them as the squishy bits. All those squishy bits also stop. But they're not like attached to anything. They kind of just all float around in there, right? If I were to actually like diagram, right? Lungs, your stomach is below that. You have a spleen, liver, kidneys, pancreas, intestines. They're all just kind of hanging out in there. Oh, your heart, you know. They're not actually physically attached to anything. They're kind of just floating. And what they're going to end up doing is going, for the record, 25 meters per second. It's like 60 miles an hour. So they're going like 60 miles an hour. And then they're not going 60 miles an hour. And they're going to slam into those bones. They're going to slam into each other. Is no bueno. 30 meters also, just for the record. If you remember how big my room in school is, right, from the very front of the room where the weight is all the way to the back, to the storage closet, that's 15 meters. So you're stopping over the course of 2 of my rooms. That's actually a really long time to be stopping and braking. And this is a very uncomfortable acceleration to be feeling. Alright? So, again, I harp on this. I tend to harp on this. Please drive slower, drive safer, because chances are you don't have that much space when you see a deer in the middle of the road. And this acceleration is no good when it comes to, like, sudden body motions. Alright? Now, I wanted to use this as an example just to show you the timeless equation. It's again, if it feels like you can't get anything done because you're missing time, try this out. Okay? There are 5 more questions to practice for the quiz. I will put up solutions the day before F day, so E2 day, evening. On E2 evening, I will put up the solutions to those so that you can check yourself. The quiz will likely only be 2 or 3 questions, much like the practice questions. They'll be short answer, so show your work, figure out what equations you have, show your variables, show me each step so that I know I can follow your process. If something goes wrong in your process, but you're mostly right, I can give you most of the points. But if you only show me beginning and the answer, I'm not going to make any guesses. All right, so please show your work. And if you have questions, please email me. Find me during school, find me before school, do something. All right, but contact me somehow. And finally, because it's the end of the marking period, go back, double check, triple check my CBA. If there is something missing, if there's something that's a 0 right now, but you know you did it, submit it to my CBA, and then send me an email saying, Mr. Kalimlim, I know that I was missing this, but I turned it in now. Can you please look at it, right? I'll grade it. It'll be late, but better late than 0, okay? So, yeah. Make sure you get that stuff in. Make sure you're careful when you're reading. And if you have any questions, let me know. Quiz is on F day. Your work is really to kind of do those practice questions to be ready. Email me with questions. Otherwise, I'll see you on F day. Take care, physics.